Okay, as you can see, this is the login page of the management portal. This login page is from Keycloak, which is the tool used in aerOS for the identity management and roles validation. We are going to use the OAuth 2.0 authorization code flow in order to perform this login.
As you will see now in the demonstrator, we can say how the feature of having role-based access to the platform is created, because two different roles come with different capabilities of managing and using the portal. One is only able to see the actual deployments, and other one, and also the domain, and the other one is basically able to do everything, like deploying the services and checking all the data of the continuum. So back to you, Rafa.
Okay. So now we have logged using this IoT service deployer user, as you can see, and as Nacho has explained, this user can only create a deployment and list all the deployments. Now we are going to make the login using a user with an assigned role of domain administrator. Now you can check that the menu contains more options. For instance, we can check the domains available in the current continuum that we have built for the demo. And if we go inside, for instance, the Cloudflare domain, we can see the list of infrastructure elements, and the same for the Demonstrator domain, which consists of 5 infrastructure elements.
As you can see, then the two IoT domain and cloud are already integrated in our portal. You have been able to see. Now we proceed with the actual deployment of a service. And as I said, we want that this is in a way done automatically by the aerOS system. One of the services that I have explained have already been deployed manually because we wanted this service to run in the infrastructure element that has the actual IoT device close to it. However, we will be seeing how this specific service for controlling the car will work. But first, I will give the floor to our colleagues Spiros and Andreas that are in Greece with the car to see actually that it's working. So
this is the 5G car. It's connected to the Demonstrator's aerOS domain as an infrastructure element, and it's equipped with a sonar sensor in the front, GPS metric, and 5G HUD. Thank you, Nacho. The floor is to Rafa.
Okay, I was preparing the deployment of this manual service that will be deployed in the selected infrastructure element, that is the Raspberry Pi, which contains the car and the engine. Okay, now I'm going to deploy it. And in a few seconds, you will be able to check that the car is in a starting status, and it's running. Okay, this deployment has been done in a manual way. Now we are going to deploy the controller module that will be the one that will be controlling the car. And now, for that, a moment, I will fill the information. I will choose now the automatic mode.
And here, as you can see, once one of the services is deployed manually because we want it to be running where the car resides, of course, because it's to get the data and put it in the data fabric to be accessible for everybody. And the second one, as we really do not care where it runs because it's a service that does not have dependency on where it runs, we want the intelligence of aerOS to actually deploy it in the most relevant point of the continuum based on the service requirements that my colleague Rafa, you are saying, is putting in the portal, such as the memory minimum that is needed to run, the minimum number of CPU cores, etc. Therefore, with the proper configuration needed, of course, for running this service, it's been prepared and it's able to be orchestrated thanks to the intelligence of aerOS. So
now we are going to deploy the service. And now Vasilis will share his screen.
Okay, so let's see the request for deployment over the continuum. How does the aerOS provide the functionalities of all the components, the orchestration components, to deploy all these components across the continuum and all the integrated domains? So we have requested the deployment of two services, and let's see how is this perceived by the view of the eyes of the continuum. So these requests have been first of all received by the front end, the API exposed by the high level of orchestrator. It receives the request, it creates the entities across the domain, and kicks off the orchestration process. Now, the second step is in the data aggregator, has received all the requirements and the constraint for the service deployment of the service, and has chosen the candidate infrastructure elements that can host the service. For one of the two services, this was pre-selected, and it provides this to the next steps. But for the other service, that it was left to be handled by the AI and the intelligence supported decisions, it has made the selection of a lot of infrastructure elements and has proceeded to provide this to the allocator. Now the allocator, which in fact it implements the AI supporting decision engine, it receives all these infrastructure element candidates, and it makes out of them the best choice for the placement of the specific service. So we see that it has made the choice, and it provides this choice to the further, which is the deployment engine. Now the deployment engine decides and understands if this deployment should be local within the domain or across the continuum. Now, as we said before, one of these was deployed locally, and we can see it in the here. It's deployed here, and it's one of the two services, and we can see its description. Okay, and this is the describe. We see that it has pre-selected a node, a working node infrastructure element, which is it's in the MVP one domain cloud Pharaoh. It has the image that we have specified, fulfills the networking capabilities that it's requested and supposed to support. It has some environment variables in order to run properly. We see that it's successfully deployed, and we see that it's in a running state. Now, on the other service component was pre-selected that it should run in a Raspberry Pi that is supported, and it's located in the Moctos, as Andreas showed before, all the sensors and the GPS and the 5G HUD. We see again that this is the pre-selected infrastructure element. It has the container that we have chosen to support the image that should support this deployment. It has all the networking capabilities. It has the environment variables that support this deployment. It's running properly. We can see also that this service has already started and has started reporting the status of the car over the continuum. So the high-level orchestrator, the orchestration above the continuum, has worked properly and allocating the best placement according to constraints and requirements, the service components to be deployed.
Now we are going to check that effectively this is actually moving the car, because we want to control from a different domain. So I ask again our colleague Spiros and Andreas to show us that in effect this is actually moving. So if you could again share what's the status of this car.
Okay, so,
Thanks.
So we can see.
Of course not so.
Until Andreas will get the camera, we see that we have a reporting here. One of the analytic tools of the continuum we are using and have embedded, and we can display all the metrics reported both from the vertical application and from the hosting infrastructure element. So once the car is moving, we see that all the metrics are updated. So let's wait for the application to start, move the car, and okay, let's wait a little for the application to send.
Here you can observe that one of the aerOS traits, one of the features that we wanted to demonstrate, is basically the integration of the embedded analytics tool is there.
Now that the controller application has provided the move command, we see that the car is moving, and at the same time we can see the Grafana analytics tool that's embedded that the status is changed. It's still running. We also see that it's updating the coordinations. It reports its current location, and reports other metrics like the hosting infrastructure element usage, capabilities and availabilities, and also the distance. We see when it goes closer, they all change, and the signal quality. So it's running, it's reporting. Okay, so now we are waiting for the car, the decision to stop this. We see that they update the car and the continuous update of all the metrics of the car. Now, once the application has decided to stop it, now it automatically stops. You can check from the camera that the car has been stopped.
Okay, now if we go back to the domains list, you will see that we have a new domain, the mobile domain, and we can also check the details of this domain. And now this domain is composed by two infrastructure elements, the computer and the Raspberry Pi that has shown my colleague Nacho some minutes ago. Okay, so now we are going to test a manual overload of the infrastructure element in which the car controller was deployed.
Yes, at this point, as I said during the flow, what we want to demonstrate is that once everything is there, we want to demonstrate the other capability of aerOS, which was autonomy. We want that when a service doesn't perform okay, or if a part of the continuum overloads, the meta operating system automatically recognizes this and performs a reallocation of the service to keep the service the same level of working transparently for the user, but an actual migration has happened. So this is what we are going to see. For doing that, what we have created is a capacity to create rules in which if certain infrastructure element is overloaded further than a specific threshold, then we request the reorchestration of that service. And this is what my colleague Rafa is going to show.
Okay. In order to perform this artificial overload of the infrastructure element, we are going to deploy a Kubernetes job. This job, or the manifest to run this job, has been uploaded to the package registry of our GitLab instance. As you can see, we have here this YAML, and now I'm going to deploy this manually just by calling to GitLab. Now, deploy the job, and now, and check that the job have been deployed, and some seconds later, we will be able to check if that the infrastructure element has been overloaded.
Okay. Should be easy to overload it. Check.
There you will see that the node was in the cloud domain in this infrastructure element has been overloaded. Therefore, the service should have been orchestrated, right? So we proceed to validate that this reorchestration will be performed.
Okay.
In that regard, we'll see that the service is still running there. It's in our continuum, but if you check, now it is no longer running there. Well, it will be no longer running there, and it will be migrated to a different domain. With this part of the demonstrator, it will be clear that once we are able to set up these rules that right now are just configured for a specific purpose of this demo, but it will contain an API for user modification within the plans of Work Package 3 that you will see, we can effectively check how it reorchestrates a workload going on. And you see that here, instead of running in the cloud domain that we had, it has been moved and it's running in our mobile domain, actually in the laptop. So it has been migrated here automatically. However, for the user, it's still working, and we could clearly check. So
we can see that the whole status of the working of the service component, the whole life cycle management is taking place from the beginning to the end. we can set and record and report on the lifecycle management state at this point. It's handled, it's started, finished, failed, terminating, starting, and it's reported. And everybody that wants to make access to this information all over the federation can we make use of this information to present it to the users or to build added value on top of this. So full life cycle management for the service components. Now Rafa will show us the last step of finishing these service components of how to terminate this reporting, stateful life cycle management through all the process of orchestrating over the continuum and over the infrastructure elements.
As you can see, I have deleted the service and the service component is being removed. Okay, and if we check now, this has been finished. And if we go to the Kubernetes cluster, it's being terminated.
Well, therefore, from the user perspective, you will be able to cover all these traits that have been explained: autonomy, capacity of reorchestration, different entities with different heterogeneous resources conforming a common computing continuum from different countries, and some that are being able to be incorporated on the fly to our own continuum. Here, the demonstration is finished. Thank you very much.